Hello viewers, welcome to another tutorial by Project Maker. In this video, I will be demonstrating you how we can implement priority queues using STL libraries. Priority queue is a data structure specially designed for Maxif and Minip implementation. So if you don't know about Maxif and Minip, so let me just give an idea about what is it. In simple words, a stack with highest element on top is called as Maxif and a stack with smallest element on top is called as Minip. I hope you have got a clear idea about what is Maxif and Minip. Now let's try to implement these two concepts using priority queue. So without wasting any time, let's move to our destination folder. So as you can see, I have already created a priority queue file in front of you. So let's open the file. As you can see, I have simply written basic C++ template already in this file to save our time. At the first line, I have included iostream package which is for C in and C out, and next is I have included queue package for priority queue implementation. Let's move to the main part of implementation. How to declare a maxi. So to declare a maxi, we have to simply write priority queue priority underscore queue and the data type of it and simply the name of the queue. So let's say I will just write it as maxi for better understanding. Now let's try to insert some elements. This time I will be inserting elements in any random manner. So I will write maxi dot push the element which is 1, maxi dot push. Now let's write 4. I will just copy this to save the time. Let's insert 5 elements this time. So let's say 3, 2 and 9. Let's say 8. In this way we have inserted 5 elements in our maxi. Now let's try to print the top element of this maxi priority queue. So it should be in 8 as 8 is the highest element we have inserted till now. So I will just write cout top element is, and I will just write maxi dot top and endl for better understanding. Now let's run the program. So as you can see, the top element is 8. If I try to visualize how elements are stored in maxi priority queue, they are in this format. So the first element will be top, which is 8, second will be 4, after that it will be 3, after that it will be 2, and at last it will be 1. So this is maxi implementation using priority queue. Now let's try to delete an element. Deleting element is very easy, just type maxi dot pop. This will delete 8 from our maxi. So now let's try to print the top element once again for our better understanding. So this time I will just copy paste the above command and it should print 4. So let's verify it by running the program. So as you can see, initially the top element was 8 and after that it has become 4, which means that the top element 8 has been removed from our priority queue. Now let's move ahead. Now let's try to find the size of this maxi. So for that I will just type cout the size of maxi is, I will just type max underscore heap dot size. So this will give us the size of maxi and ended for better understanding. So let's run the program. As you can see, it has written the size of maxi is 4, which is correct because we have deleted 8 from our maxi and remaining size will be 4, so our answer is correct. Now let's move ahead. The next is printing elements. So to print element, we will be using the traditional queue method, which is while in bracket check if maxi is not empty. So this empty function will tell that continue this loop till maxi becomes empty. After that I will just print cout maxi dot top, and after that I will just here some space. I will just give here some space, and after that I will just pop the top element. So maxip dot pop. So this will print the top element and it will pop it. And at last I will just write cout and for better understanding. So now let's clear the output and run the program once again. So as you can see, the elements in maxip are 4, 3, 2, 1. So it has given us the output in descending order, and this was all about printing the elements in priority queue. Now check for empty array. So we will be using the same function, which is cout is maxip empty. Now let's run the program. As you can see, is maxip empty, and it has written as 1, which means that our maxip is really empty. So now let's move ahead. I have already checked the size of maxip, so we will not repeat this concept. Now I will just comment out this all, and let's move to the next concept, which is minip implementation. Don't worry, all the code will be available to you in video description. Now let's move over the minip implementation. So first is declaration. Declaring minip is quite difficult as compared to maxip, so I will show you how we can declare a minip. So for that I simply write priority queue int, which will be a data type, and we have to write here vector. This is the syntax to implement minip, so we have to remember it. I can't help you with that. Greater and the data type of it, which is int, and the name of minip. So let's say we will give the same name, which is min underscore heap. So this is a declaration of minip. You have to remember this declaration. Now let's try to insert element in minip. So inserting element is as same as maxip. So I will just write push. This time I will write 4 at the top and just copy paste it for saving the time. Let's say 3, 2, 1. So we have inserted 4 elements in our minip. Now let's try to print the top element. So according to the minip logic, it should print to 1 as top element. So let's check it is right or wrong. Top element is minip dot top. Okay, and then so as you can see, the top element is 1. So if I try to visualize the arrangement of elements in minip, so it is this way. First at the top is 1, after that it is 2, after that it is 3, after that it is 4. In ascending order, the elements are arranged in minip. Let's move ahead. Deleting an element, so it is as same as maxip. So just pop command to delete it. So I have to also write, and now let's check whether the element is deleted from it or not. The element to be deleted is 1, and it should print as top as 2. Let's verify it. So as you can see, initially the top element was 1, which is here. After deleting one element from minip, the top element has become now 2, which is correct. Now let's move ahead. Next is size of minip. So it is similar to maxip. So I will just say the size of minip is, and I will just write minip dot size, which is 3 in this case, because we have deleted one element from our minip and remaining elements are 3, so the size should be 3, and our prediction is correct. Now let's try to print element from minip. So the printing element is also same, just declaration of minip is different, else everything is same. Min underscore heap dot empty. Let's verify the printing element whether the elements are arranged in ascending order or not. So I will just print cout and min heap dot top, after that some space and just pop element min heap dot pop. So and after that I will just write cout and for new line. Let's clear the output and run the program. So as you can see, the elements are arranging 2, 3, 4, which is ascending order. After implementing this concept, we can come to a conclusion that element in max heap are always arranged in descending order, whereas the element in min heap are always arranged in ascending order. Now let's just check for empty array. So which is also same. So I will just write cout is empty and just type max heap dot empty. It should return 1 because our heap is now empty. Now let's run the program. It is giving an error. Oh, it should be min heap, not max heap, because we have commented out the max heap. Now let's run the program. As you can see, is empty. It has written as 1, which means our min heap is also empty. This was all about priority queue and how to implement max heap and min heap using priority queue. Here comes the end of this video. If you like this video, then don't forget to share it with your family and friends. Thanks for watching this video.